All right, example 4 is a find the equation of the tangent question, another typical question where there's the function. We've got a specific value, x equals -1, where we want to find the equation of the tangent. So how do we find it? Well, we know it's going to be, it's got to be in this form, this sort of thing, where our x1 is -1. That's the value that we want to find the tangent to. M is actually the derivative, right? M is the derivative when x equals -1. So we'll do that over here. What's y1? Well, y1 is the function value at x equals -1. So what do we got? We got -1 over 3 times -1 plus 2 all cubed. That's 1 over, what is that? -3 plus 2 is -1 cubed is -1, right? So y1 is also -1. And then the derivative, right? We've got to find the derivative of y with respect to x. And how are we going to do this? Well, I suppose we could use the product rule, right? Write this with a minus exponent, something like this. This isn't how I'm going to do it. I'm going to use the quotient rule. I could do it like that, and I know some of you like doing it like that. I'm going to use the quotient rule. And off we go. So the quotient rule is derivative of the top, write down the bottom, minus write down the top, derivative of the bottom. Now the bottom is a chain rule, right? The chain rule, the 3 comes down, and then baby stays inside. The exponent goes down to 2, baby stays inside. Then the derivative of the baby. Derivative of the baby is just 3. All over the bottom squared. And notice that there's some simplifying that can go on here. Even though I know since I'm substituting in -1, I could do that anytime I want to, right? It's just a value. I don't have to simplify, but it's nice to see some practice simplifying. I've got a common factor of 3x plus 2. See that? I've got 2 copies there, actually. I got 3x plus 2 squared that I can factor out. Nothing else, I don't think. Maybe a -1 I might want to take out. I'm going to leave it, though. What the heck? There's the -1, and one more of those left over. That minus I write down, and what else do I got? That's gone, and I have plus now 9x. And if I make an arithmetic error, well, I guess you'll just have to scream at me through the computer. Apologize for the arithmetic error. And so cancel out those 2, and leaves me with 4 of those on the bottom. Make that thinner. X plus 2 to the exponent 4. Tidy that up in the top. And I got -3x plus 9x is 6x. And the -1. And now if I evaluate at x is -1, what do I got? I got -8 over, and this is -1. We've calculated that already, to the exponent 4 is 1. So it looks like the slope might be -8. The slope is -8, and then I can just substitute in. X is -1, so that's a plus. And then tidy this up, I guess. Standard form, why not? Y stays there, put the 8 on the other side. Done. One thing I just want to mention that's kind of neat in passing, I haven't mentioned this before, is I saw just recently a neat form of the equation of a tangent. Y, remember, is like f at x. Y1 is f at some function value a. Here x has got a specific value a. And then the slope, well, the slope is f prime at a. And then this part becomes x minus a. So if I move that to the other side, here's the equation of the tangent kind of in grown-up terms. I don't know, my pen's going funky on me. The pen started wandering. Oh, maybe there it came back. Weird. This is a pretty nice grown-up version of the equation of a line of tangency to some function f at x at the point x equals a. F at x equals f at a plus f prime at a at times x minus a. That's the equation of the tangent. That's pretty neat. We haven't seen that before. There's a new little bonus learning just before the exam. Okay, that's all I have to say about that exam. Sorry about the wandering pen.